What type of triangle is formed by the points x, y, z? Select all that apply. Okay, we got equilateral, scaling. The answer ends up being isosceles and right. All of this you could figure out by finding distance and also using slope, like the equilateral, scaling, and isosceles. These three words are specifically about the side lengths. Equilateral means all the sides are the same. Scaling means none of the sides are the same length. Isosceles means at least two of the sides are the same length. D and E are about angles, and that's going to relate to slope, so we can do that in a second. I need to find the distance. I need to find the length of all these sides, which is going to be distance. And I'm going to use right triangles to do it a little faster. So this side, if I make a right triangle, it's 3 and 2. So that's 3 squared plus 2 squared. If I'm looking for this side length, that's also 3 and 2, this right triangle, so this is the same length as that. Whatever 3 squared plus 2 squared gives me will be the length of both of those sides. Then x to y, my right triangle is 1, then 1, 2, 3, 4, 5. 1 squared plus 5 squared. If you're confused about the way I'm doing distance with right triangles, you should watch an earlier video because I described this process. So I don't even need to evaluate these. I don't think I'm going to. I can just tell that, like from these numbers, that these are going to come out to be the same. So these sides are the same length, and then this is going to give me a different number. So xy is a different number. Maybe I should. 3 squared is 9, 2 squared is 4. So this side and that side are the square roots of 13. This one is square root of 26. Those are my 3 side lengths. 13, 13, 26. So this is an isosceles triangle because 2 of the sides were the same, 1 was different. So click isosceles. It's not scaling because 2 are the same. It's not equilateral because they're not all the same. Now we're going to look at the slope of each of these lines to find out if it's a right triangle or not. Equiangular would just, if it was equilateral, it would automatically be equiangular. It couldn't be equiangular if it's not equilateral. I don't believe that would be possible. So for slope, we need to find the slope of each of these sides. Zy, I have a rise of 2, run of 3. Rise over run is how I find slope. And those are both positive, so the slope is 2/3. You can kind of see the connection between finding slope and finding distance because we had 3 squared plus 2 squared to find the distance. This side, x to z, I could go up 3 and then back 2. So that's -3 over 2. And then for side xy, I go up 1, back 5. So that's -1 over 5. Because the 1 was positive, and the 5's negative. So that gives me negative slope. And I see a connection. -3 halves and 2/3. These are like opposite reciprocals. Like the fraction is flipped. And this is positive and this is negative. So these lines are perpendicular, xz and zy, which means it's making a perfect right angle. So like visually, you might have just assumed it's a right triangle, but you don't actually know that without checking the slope. So it's also a right triangle, isosceles and right.